Welcome to the plenary session on the panel discussion on aerospace systems engineering in an AI-dominated era. Systems engineering is a transdisciplinary and integrative approach to enable the successful realization of systems. In aerospace, the significance of using systems engineering has already been well established, but the challenge now is that aerospace systems are becoming more and more complex, and there is a lot of drive towards making the systems more autonomous, inculcating kind of human-like decision-making and autonomy into such systems through. So it is in this context that we are convening this panel. So I have the privilege of introducing the moderator of this panel, Dr. Devanandam Henry, who is a principal consultant at the Blue Key Solutions Private Limited. He holds a BTech in Aeronautical Engineering from Madras Institute of Technology, Chennai, and an MTech in Aerospace Systems Engineering from IIT Bombay, and a PhD in Systems Engineering from Stevens Institute of Technology, USA. He started his career as a scientist in ADA, where he worked on the design and development of the Air Force and the naval versions of the light combat aircraft, Tejas. In US, he was a research engineer with the Systems Engineering Research Center and an assistant professor of systems engineering. He has worked on a number of systems engineering-related projects sponsored by various agencies, including US Department of Defense and the International Council on Systems Engineering. He's currently a principal consultant at Blue Key Solutions. So I'd welcome Dr. Deva to take over the panel.
Thank you, Ramki. I will request the panelists to come on stage, and then I'll introduce them. Mr. George Coyle Pillai, Dr. Narayan Ramachandran, Dr. Abhay Pashelkar, and Group Captain Aslam Khan. So is there a mic? Okay, Good afternoon, everyone, and welcome to this systems engineering panel discussion. Let me take a moment now to introduce each of the panelists on stage and then get on to the topic of what we're going to discuss today. I'll start with my far left, Dr. Abhay Pashelkar. He is a graduate of IIT Kharagpur with a BTech honors and a graduate of ISc with a master's both in aerospace engineering. He has a PhD from ISc and was also a postdoctoral fellow at NTU Singapore. He joined the Flight Mechanics and Control Division of NAL in '93, and in the division he became group head and deputy head, and since 2018 he has been heading the Systems Engineering Division of NAL. He has worked on a number of national projects like LCA and SARAS. He is presently also the program director for civil aircraft projects at NAL. It's a pleasure to have you, sir, and welcome to the panel. Let's give a round of applause to welcome Dr. Pashelkar, please.
Thank you.
To his right is Group Captain Aslam Khan. He has a diploma in flight test engineering from Indian Air Force Test Pilot School here in Bangalore. He has a bachelor's degree in mechanical engineering from Mumbai University and a master's in aerospace engineering from IIT Kanpur. He started his aerospace and defense career as a commissioned officer with the Indian Air Force in 1987. He has worked extensively on flight testing and airworthiness certification of military aircraft, including the LCA. Currently, Group Captain Aslam heads the strategic business initiatives for HCL's Aerospace and Defense Business Unit, a position he has held since 2016. He has led the HCL engineering teams that work with OEM and Tier 1 customers for multiple aerospace and defense systems engineering projects. He has also worked as a multi-services delivery head for HCL's large engagements covering engineering, R&D, and IT in Europe, North America, and India. It's a pleasure to have you on stage, sir. Welcome. To his right is Mr. George Coyle Pillai. He is a graduate of IIT Chennai, Madras, with a master's degree in aerospace. He has 33 years of industrial experience in the field of aerospace. He has led the engineering development of a number of avionics products in the domain of communication, navigation, guidance, and surveillance for many aircraft programs, including the LCA. He has led the engineering efforts of customizing and integrating Honeywell inertial navigation system in the Indian indigenous artillery platforms and in installing GPS-based landing system at Chennai International Airport. In his current role, George is the software chief at Honeywell and has the design authority for the verification and validation functions of Honeywell's aero engineering development programs, where he also explores application of emerging technologies for improving product quality and development lifecycle. And I would also wish to add that he is one of the recent expert systems engineering professional recognized by INCOSI, the International Council on Systems Engineering. Welcome, George. And to my left, we have Dr. Narayan. He is an accomplished mechanical engineer with a PhD in sensors from VTU Belgaum. He has over 36 years of experience at the Liquid Propulsion Systems Center, ISRO, out of which 25 years in a leadership role in various positions ranging from division head, group head, to deputy director at that time of his retirement in 2020. He is an expert in spacecraft propulsion systems, monopropellant and bipropellant, and has played a stellar role in the system's reliability, certifying over 50 spacecraft propulsion systems for flight. Including the first indigenous communication satellite INSAT-2A in 1992, and later on with Chandrayaan, Mars, orbital mission MOM, and spacecraft recovery experiment. As the chairman of the failure analysis committee, he has done failure analysis of various components and subsystems. Perhaps the only person on stage without a direct ADA LCA connection, but welcome each one of you. And so the topic that we're going to explore today as a group, for the panel, is aerospace systems engineering in an AI-dominated era. So this day has certainly been an AI-dominated day at AeroCON 2022, right? So this is what we're going to be looking at. How we're going to schedule our panel is that I'm going to take a few minutes to set the context of aerospace systems engineering and AI. And then I would welcome each of the panelists to present their position statement on their take on AI and systems engineering. And then we'll have a couple of questions that that we'll moderate here. And then we'll open up for questions. This is a panel discussion, and I would really request all of you as the audience to engage. So we request your participation as well. So please be ready with your questions. And then we will close with a closing statement from each one of them. So this is the plan for the panel. I'd like to start by asking two very basic questions, which is what is systems engineering and what is artificial intelligence? We have heard about AI since morning a number of times, so we all have a fairly good idea of what AI is. And thanks to Yoga during his talk and Ramki in the introduction also mentioned what is systems engineering. So just to reiterate, systems engineering, this is the way INCOSI has defined. This is the more recent definition of systems engineering, which came out in 2019, which is systems engineering is a transdisciplinary and an integrative approach to enable the successful realization, use, and retirement of engineered systems. So the focus is on engineered systems, And it's a life cycle approach, so we're looking at the realization, use, and retirement of these systems. And in doing this, we are going to use a number of principles, concepts, scientific, technological management methods. So it's a combination of many things that comes together without the bounds of any discipline. That's where the word transdisciplinary comes in. So this is what we mean when we say systems engineering. And when we say artificial intelligence, all of us may have our own ideas of what that is. It is, in some sense, a simulation of human intelligence processes, but performed by machines, especially computer systems. So this is the kind of understanding of what AI is. And as some of our presenters before the lunch, we were talking about, a gentleman from Hexagon and then from Collins, AI is not something new. It's been around. So the word was first used somewhere in the 1950s. And then we've seen a lot of Hollywood movies, right? So a lot of things that have come. So the famous movie by Spielberg, Artificial Intelligence, AI, came out in 2001. And it was based on a story that was written in 1969. Okay, so AI has always been around as a term, as a concept, and people have been exploring it. But today when we talk about modern AI systems, and the difference is that when we look back at the past decade or a couple of decades, processing, computer processing, data storage, analysis, all those techniques and tools have improved significantly, and that has influenced AI and the practice of AI. So today when we say AI, it falls under two kind of categories. So one is systems where the decision-making logic is explicitly pre-programmed. Okay, so that is one category of AI. The other is where systems are taking the decisions themselves. There is a decision-making capability that is learned from data. So that is where machine learning comes in. So when we say AI, ML, it's a mix of this. And we are somewhere in the middle of this. And as you have heard also that so much of progress has happened, but much more progress is yet to happen to come up with truly autonomous, truly AI systems. So when we look at both of these, when you look at SE and AI, the interesting thing is there's an interesting interplay between them because they tend to contribute to each other and they can influence each other. So that is where when we look at INCOSE, the International Council on Systems Engineering, and how it is looking at these two emerging areas, today we talk about two terms. We say SE for AI and AI for SE. Okay, so both of these are talked about in the context of systems engineering and AI. What we mean is that when we say SE for AI, it is using SE methods to design and operate intelligent systems, AI-enabled systems. So that's where systems engineering is contributing to development of AI. And on the other side, AI for SE means you're using AI to enhance and assist systems engineering processes, methods, and tools across the life cycle of the system. So there is an interesting interplay between the two. And in our panel, we're going to explore kind of both of them, SE for AI and AI for SE, because sometimes that could be a gray area. There is a significant overlap between who is contributing to what. And the message is we need both. Okay, so we're going to go into a round of position statements from each panelist. And we'll start with Dr. Abhay Pashelkar, who'll talk to us from more of a sensor fusion point of view. I request Dr. Pashelkar to give his.
So thank you, Deva. Yours, your enemies, and so on. And so you have a fairly complex scenario where you are entering in. Today we are talking about beyond visual range and so on. So clearly, when you enter such a theater, there are many actors in that theater. There are many systems which have differing capability, and somebody who is either on the offensive, that is ourselves, if you position yourself on the left-hand bottom corner, you would typically like to have a situational assessment of what's happening. So that's the very first thing that you need to do. So that clearly points to a need to be able to sense. So you have various sensors on the aircraft, let us say, and you have also sensors on other aircraft, friendly aircraft. You have aircraft which are passing on information through maybe a data link or something. You have unmanned aircraft which are leading the way, for example, in order to have less attrition on your side. And those are then looking ahead and giving you data. You have passive sensors, you have active sensors. All of those means a lot of data. And so the very first layer, if you want to think of in terms of the system that you're engineering on the left-hand bottom side, would be some kind of a sensor fusion, because you need to be sure from multiple sources what information you are getting, it's validated and it's correct for you to take a decision, because the ultimate idea is to take a decision based on that. So that's where the first level of, first layer of sensor fusion becomes critical. And then, since you want to take a decision, you need to decide whether something or the other is a threat, or it's not a threat, or is going to be imminently a threat, in which case you need to be able to then do some amount of processing, probably purely based on the kind of information that you have with regard to that particular target, either a moving or a stationary target. And then the last thing would be whether, after processing all this information and arriving at a threat assessment, are you in position then to take any evasive action, automatic action? So that's the last stage. So that would be not just decision, but also really action. So whether you would like to automate all these three phases, clearly sensor fusion is very much possible. Whether you'd like to have the threat assessment being done by a machine as opposed to a human pilot, somebody who's processing the information in all 360-degree directions. And lastly, whether you want to allow a machine to then take evasive action. So all of this now depends on what is the rate at which this information is coming, and whether it is within human capability to do all those actions and then be able to, basically win in some form in the battlefield. So that's really where you have these layers of AI coming in, which will help you to take those decisions. And machine learning would help in a sense that when you run these scenarios, how do you train such a system? How do you train such a system to be consistently giving you a probabilistically better chance of success in that battlefield? So that's when you need to probably create lots of simulation, modeling, and so on, throw at this system various kinds of scenarios where you already have the answers to that, what are the best strategies, and then see how the system performs and probably train it. And so that is where the machine learning aspect will come from. So that's how we see, at least I would like to see AI and system engineering playing together for the kind of problem statements that we have today when we try to design an aircraft, at least a fifth plus generation fighter aircraft, let us say. So that's what
Thank you. Thank you, Dr. Bashelkar. So yes, certainly there's a lot of data coming in, and that's where sensor fusion comes in. And when all this data comes in an aircraft, in a typical fighter aircraft or even a civil aircraft, there's an overload of information, and the person sitting inside the cockpit is the pilot. So I would like to request George Coyle Pillai to give his thoughts on the aspect of AI in the cockpit.
Yeah, thank you. Yeah, so since morning we heard various views. So the more we hear, the more we read, the thoughts are converging, right? So mostly, many of us talk about the same thing in AI. So we heard that one of the presenters said in 90s he worked on AI, and then just now our panel moderator said, so it has been there for 50 years. Why then there is so much talk now all of a sudden about AI? That's because one reason is the processing power has tremendously increased, and there is general interest, but people are seeing for themselves now what it is doing in the other civil areas or applications. So there is tremendous interest that has come in about AI. But aerospace in general has been the last one to take it because of the safety criticality, right? So I have heard from people who worked on aerospace for many, many years saying that when we moved from artificial horizon to a 2D kind of symbologies, there was a lot of concern. Everybody thought, oh, pilot is going to make missed error, and then it's going to lead to a lot of accidents. But over a period of time, that has become the standard, right? So in our own time, we have seen the touch screen everywhere. Now it was being applied, but it has taken almost 20 years, 15 to 20 years to get into the cockpit. Same is true even for AI. It is nothing, I'm not bringing a new view. But are we ready to bring AI into the cockpit? That's what I wanted to talk about. So my opinion is with the processing power already there, lot of research going on. It is little by little we have to get into the, bring the AI into the cockpit. So it's nothing new. Say many years before we have read that computers beat the chess champion, right? The first time when computer beat the chess champion, it was a great talk. But was it intelligence? Maybe not. It had the processing power to work through large number of maybe moves and pick up what is the best possible thing. But still, even in aircraft today, most of the long distance aircraft just fly with autopilot. But why do we have pilots there? The corner cases. Emergency occurs, that's when pilot has to come. So what makes the difference? We generally say human brain has got maybe 100 billion neurons. That's somebody said 86, somebody said 100, some number, huge number. And then they say it is even 30 times more powerful than the known supercomputers. So in all that, we see the AI and computer are able to do lot of processing and have tremendous memory, very good memory, and have the capacity to assist, right? So, but human has got something like intelligence, common sense that we are not able to figure out. But we are now talking about, can we get in there? Can we do a better job? So I just take one example. So there's a infamous accident, the Air France aircraft that crashed after the pitot tubes were blocked. So that was a corner case. So the sensor data was erroneous. It was blocked. So now the systems are not able to handle. So now we need pilot. So were we successful every time? Maybe not. But the probability of a human intervening that situation is better. So if we bring little bit of intelligence from the system, that would make a lot of sense for us. So to conclude, what my opinion is, now it is time. We have waited for enough time. It is time to get AI into cockpit, maybe in simpler ways to assist. That's what the regulatory agencies are trying to do. So I take another example. While you drive on a highway with an expensive car at a high speed, how would you feel? You have to make a call. Won't it be very convenient to just say call home, than taking your eyes off and then looking for the phone and then dialing it? It makes a lot of difference. So in simple terms, maybe we can bring AI into cockpit and slowly take it to the most critical things. That's how it is going to be. I don't know my time. Okay. In other, most important thing is finally, who would decide whether AI will get into the cockpit or not? It is the user, that's pilot, right? So we have to take a lot of opinions from pilots. How would he now feel comfortable if one of his co-pilot is removed with the machine intelligence? So of late, I read in the internet that pilots having used a lot of gadgets at home, so they're becoming more comfortable, more open to having assistance in the cockpit from machines. So I'm hoping that slowly, maybe 5 years, 10 years down the line, we'll start having AI into the cockpit, and the way the aircraft is flown will be totally different, and then the safety will tremendously increase, in my opinion. That's my
Thank you very much, George. As you were talking about AI coming into the cockpit, I was reminded of a video that was circulating on LinkedIn, Facebook, WhatsApp, where police pulled over a car. It was a driverless car, and there was no driver, no passenger also. So the police didn't know what to do. And they went and stopped it, and after some time, the car started going on its own because it didn't know why it was stopped. So all these interesting things we are beginning to see with autonomous cars coming in, and legal aspects, certification aspects. And that leads us to what I request Group Captain Aslam Khan to talk about from his background of certification and airworthiness, his thoughts on AI.
Given the energy in the hall, I think I'll stand and study.
Sure.
Thank you, Dr. Deva. Good afternoon, ladies and gentlemen. Given that I spend my time in the Air Force doing flight testing and certification, there is a lot on AI systems that we are talking about, but we also, yes, we need to bring it into the cockpit, definitely, Mr. George. I couldn't agree more appropriate time, but we need to do it safely. In order to do it safely, we must understand completely the challenges that are involved for a commercial aircraft. I get this question very often whenever we do discussions with our customers and in various forums, that UAVs are already flying, autonomous UAVs are flying, autonomous drones are flying, autonomous helicopters are flying, land vehicles are there. Then what is the challenge in the commercial where there is a fare paying passenger and implications of insurance, legality, and so many issues involved. So towards that, I just wanted to focus very briefly in this 5 minutes, some of the challenges that we need to overcome to ensure full-fledged AI systems into the aircraft. There are many teams which are working. We heard in the morning, there are various solutions that the industry is looking at. Dr. Jabu, I saw your machine vision automation, test automation solution that you're bringing, which is DO178. But for the complete system in the aircraft, we certainly have to cross all of these barriers, starting from that our traditional frameworks of ARP 4754A, our DO178C, etc., 254, are not adapted to AI system. We will have to adapt to new standards, which I will cover in a minute. There is this difficulty of understanding comprehensively what that AI function will do. There is a question of robustness, which we all the time we desire when we do certification, and no unintended function or no unintended behavior to take place. Then, of course, in the social media, we have seen enough the question of bias in AI system. How do we ensure that that doesn't take place when we put the AI system onto the aircraft? And of course, coming to the adaptive learning processes, so far, whatever software we certify on ground is the same software which goes onto the aircraft. But in the case of AI system, the system weights and the neural network weights will change. So strictly speaking, the software which I have certified on the ground is not the same software which is flying. And then the question comes, are there unknown functions or unknown, unanticipated behavior that can happen?
Hello.
So I have to
Hello, sir. Sorry to disturb you. It's not audible, sir. You can just close your mic. Keep the mic closer, sir. Hand mic. Yeah.
Closer?
Yeah, yes. Okay. Voice is not audible, so.
All right. Is this good?
Yes, sir. It's fine.
All right. Thank you. And of course, we have heard about some of the speakers in the morning. If you bring in AI-enabled systems, then you also have to deal with cybersecurity, data protection, and all the associated subjects around making sure that there is no somebody hacking into the system when the aircraft is flying. So next slide. Okay, so one of the aspects of software certification where I want to bring out that if there is an AI system in the cockpit, then we need some of the challenges that I can clearly see. How do I decompose this kind of an AI system or the AI part of the system into testable specific function? How do I do it and test it thoroughly and make sure that it will work on ground and it will work in the air? Similarly, how do I accommodate any unanticipated input which we have not foreseen here, but which a situation can happen? We have to make sure that the AI gives us the same response as we intended it to be. Of course, code testability, this is all the time which keeps us awake at the night to make sure that all foreseeable conditions we have tested, all corner conditions we have tested, and made sure that the software is safe or the system is safe to go on the aircraft. So next slide, sir, please. So here is where when I was studying for all these subjects and I was studying for the topic and I was seeing what FAA is doing, what ESA is doing, I like what ESA thinking is, and that is what I wanted to highlight. What is their roadmap towards certification? Because while we have given the challenges, we have to start working. As the systems are getting developed, we have to look at this roadmap to ensure airworthiness certification. So ESA roadmap says that you must make sure to build an AI trustworthiness platform. And it is not enough to just build this platform. This platform must be human-centric to take care of the fact that there are aircrew operating the system. There will be pilots, there will be other people in the cockpit, and you must make a human-centric AI trustworthiness framework which can certify such systems. So coming to the AI, to build such a kind of a framework, you necessarily have to do the analysis. And in that analysis, there is the point number 2, the learning assurance. That means instead of the traditional V curve that we saw in some of the speakers presented in the morning for system development, there is a modified approach being suggested, which is a W approach to the certification. And that W is to make sure that the learning assurance of the model of the AI system of the neural network is captured completely. There is a concept of design assurance for neural network that is being taught on CODAN, and those are the topics that they are working on to make sure that standards are well written and we are able to make sure that the AI systems are safe to fly on the aircraft. Yeah, next slide, sir. So coming to the other 2 aspects, explainability. We all know AI is a black box, and here if you want the system on the aircraft, then we have to open the black box, and the way to open the black box is to make sure that we are building systems in the AI with AI where we are able to explain the behavior under all conditions. Also on the AI safety risk mitigation, we will necessarily not be able to remove the human being for some time, sir. I am not very sure what timeline. People keep, many questions are asked from 2-member crew. Maybe I can come to 1-member crew with a connected, with the second pilot sitting on the ground, but I'm not very sure of the timeline where we will see with both pilots removed and an autonomous passenger, fare-paying passengers being carried in the commercial aircraft. So eVTOL, there is a lot of discussion, a lot of work happening, but in this space of large commercial aircraft, it is still some time away. So that is where the AI safety risk mitigation will have to be taken care of, because we must gain the public perception. Today, nobody thinks about, about his danger when he buys a ticket because he knows he's safe. He will reach the other side safely when he does the trip by the aircraft. So when we enable AI systems, we have to make sure we have the public perception along with us, otherwise solutions will not sell. People will not buy a ticket. I would not buy a ticket to sit in that aircraft. So that's about all I wanted to cover.
Thank you very much, Guru Captain Aslam. Very interesting perspective indeed, right? So, especially in the civil area, civil airspace, certification, airworthiness is extremely critical, and without that, really cannot see AI coming in. So, like to now call upon the 4th panelist, Dr. Narayan Ramachandran, and to bring a perspective that is beyond what we have been talking until now. So, an AI from a space systems perspective. Dr. Narayan.
Thank you. Respected moderator and my august fellow panelists, chair president and members of the organizing committee and intellectual audience for present here, a very good afternoon to all of you. So you might have heard about my earlier panelists speaking about the aircraft perspective. So there is going to be a total shift from that one where there is no maintainability possible as far as the space systems is concerned. So once it takes off, it has to accomplish its objectives, otherwise the mission will be construed as a failure. So with this background, how AI will be adapted to in the space systems, I would like to throw a little bit of light. But I am coming from a propulsion subsystem background, which is more of very complex subsystem and very hazardous in nature, where the inroads of AI is made in a very primitive way, whereas in the other areas, where communication as well as resource mapping and image processing and all, it has made rapid strides. And in the days to come ahead, we'll also be in a position to make it totally executive control with respect to AI. But one point I would like to reiterate is the system engineering interdisciplinary approach, what has been told from the definition from INCOSI and all, are very well adapted in our space systems, and that's why we're able to give successful launches over a period of time. So some of the few examples where the AI has been implemented and used is the autonomous control of launch vehicle and launch vehicle and the spacecraft, where the navigation control system is autonomous. And the Chandrayaan-2 was an all-powered Pragyan rover it had. And the multi-object tracking radar and the image processing and pattern recognition. Today we are able to map all the geospatial resources, and we are able to monitor the forest conservation. And in the area of propulsion technology, to ensure cost-effective, reusable and recoverable AI-based sensors are all equipped in the propulsion systems to give feedback and take decision-making in real time. Next slide, please. Possibly I would like to quote Albert Einstein, who told that artificial intelligence is no match for natural stupidity. That was in the last century, way back in 1950s. And today there is a paradigm shift in this approach, and everywhere we are seeing the advent of AI. And I'd like to tell that we are taking no stones unturned to ensure that the mission is successful. But however, it has got its own challenges and limitations, and one has to tread cautiously to implement AI in systems of high risk, especially in the area of space business. Testing and validation of AI systems is a challenge because we cannot simulate all the environmental conditions because it has to work in a very hostile and hazardous environment in space. So whatever possible to simulate and whatever the test can be conceived, it has been, we are being able to test it and validate and verify with our models. So that's a big challenge for us. And AI can never take human brain capacity, as human evolution of thoughts is fed by innumerable number of body sensors, which was reiterated by George some time ago when he told it is having millions of neurons in our 100 million neurons in our brain. So probably AI has to match those requirements, and then in the end I would like to tell that there should be a very good synergy between the academia, industry and research, because such a complex system cannot be done solely by the research organization. So the modeling and simulation should be done by the academicians, and the manufacturing capability has to be enhanced, and how to use the advent of smart materials and other things to make it more high strength and low weight is the concept of optimizing this weight in the space systems. The industry should come forward with novel manufacturing techniques, which has already come up in form of 3D printing and other things. So that we can develop a very good complex AI systems, and should have really introspect with a sound foundation of system engineering. Thank you.
Thank you very much, Dr. Narayan. Thank you all panelists for your position statements. A lot of interesting things came about, but when you think back on the whole idea of AI and AI taking some decisions that humans take based on our intelligence, I want to pose this question to Group Captain Aslam. There are a lot of challenges you talked about from an airworthiness certification point of view. But why go through all the trouble? Why do you need AI? If AI is such a trouble, why you can forget about it. But what are some benefits that we can draw from AI that we would still like to go through with it despite all these challenges?
Yeah, correct. So there are certainly a lot of advantages from aircraft operation, from being inside the cockpit. Consider we have had so many cases of problems of disorientation, pilot disorientation, because of the weather, because it is dark night, flying overseas. Some of those conditions, if I have an AI-enabled system which tells me which is the right side up, because that is what my senses are drifting, I am not sure, and I have myself have experience. So you really don't know which way is the right side up, which way is the horizon. The instruments are telling you some story, but you don't want to believe the instrument. So at that moment, if I have a mode where I allow the AI to take over and it uprights me, my senses come back and I reorient, that would be fantastic. So those are some weapon delivery, for example, of the cases where Dr. Pashilkar covered. Those are some of the areas where I would like AI system, because the workload is so intense. You're looking out for the ground attack of the enemy, targeting you, and you have to also deliver your equipment. So some of this high stress, high load area, I think there is great advantage to have AI systems for sure. Just two examples.
Sure. Thank you. So I think that's what is driving the whole thing, right? So as much of benefits we hear about AI, there's so much of challenges that we hear about it as well. But there is some advantage. There is a reason why we still want to go into AI, because there is so much that we can gain from it. Dr. Narayan, when you talked about the collaboration between industry, academia, research organizations is something that needs to happen. We have students in the audience. We had some interesting student papers as well. So what are some research topics you think that can be addressed collaboratively by academia, industry, research organizations?
Basically, what I would like to emphasize is the complexity in, as well as I'll take the example from coming from a propulsion background. So even if there is a small amount of contamination involved in the flow pipes, so it can distort the mixture ratio of a bipropellant system between oxidizer and fuel and oxidizer mixture ratio. So probably if there is a simulation model available that even if there is a change in the flow rate by even 0.001 milligram per second also, what will be the type of mixture ratio variation we can get at the end of the mission duration, whatever it is intended. At that point of time, what will be the type of performance? These type of things can be given to the academia to make a model for it and validate it. And the results and tests can be done by the R&D organizations and give the input data to generate the empirical data and give them as an input. And And we has to work in a very volatile and hazardous environment to withstand very high temperatures. The manufacturing sector can think of doing a high strength to light alloy type of thing, which are very protective coating or refractory type of materials of coating. So these are all the advanced materials which you are looking for in terms of composites and ceramics and other areas, which can be insulated and which can withstand a very high temperature, because the combustion temperature can go as high as 3,500 degree F. And these are the type of things the manufacturing sector should see. And even there should be dimensional stability at extreme temperatures. So these type of things the manufacturing sector can take it up as a challenge. And if they come out with this one, all these three can be integrated and a proper ecosystem can prevail, so that we can deliver a product which can be part of our subsystem, which will deliver the goods for the space sector.
Thank you. So I think as Dr. Narayan was explaining, he gave a very specific example from a propulsion system point of view, which is his expertise. And I'm sure, I think this is where the challenge is, that, to make AI really usable, we have to get into the specifics. So it is one to have general methodologies, general approaches, and all of that. But when we need to go into using AI in our real life systems, it has to become very specific. And so this transition from research to product development is something that's very important. And so, George, how do you think this transition can happen? Because there's so much of research, we are still kind of in a research mode, but and you said it's time for AI to get into the cockpit. But where are we in this transition? How can we accelerate this or make this more efficient and successful from transitioning from research to product development?
Yeah, sure. So some of the examples I took also how AI can help when I talked in the opening, but there are two things I think now has to be done for AI to get into cockpit. First thing, the maturity itself, the research and then work done on the AI has to mature. I take a simple example. I love, as I said, I love Siri to, while driving you can call, you can now ask map to do, all that is very good. So when I am in a very important call, now with a customer, suddenly Siri will talk. I understood this, I'll do this. No? I have to tell the other guys, oh, I'm sorry, it is Siri. So that's fine, now when I'm in a call. But pilots are going to be, he talked, right? Maybe something, he talked. So, right. No.
Did you pre-program this or?
No. Okay. When I said Siri,
automatic.
It got alerted. Okay, fine. So pilots are not going to be happy about it. So I remember in one of the aircraft program, where I was front-ending the avionics function and integration, pilot after the test flight will come and shout, can you switch off that radio altimeter? Now I'm coming to land, it says radio altimeter fail, radio altimeter fail. I would rather do it myself than depending on your system. It becomes a nuisance, right? So that is what the technology has to mature to get into AI. It is okay to put it in the watch or phone. So not only the development side, the verification side also. Right? So there is a thought that traditional methods will not be okay to apply to give confidence, assurance to the AI. So can we shift the this load onto the development process? So what are the development process? DIVO 178C supplements, right? But I see AI is maturing faster than formal methods. Whenever I have a discussion, now we say, is formal method good enough? Now is it matured enough for us to get confidence on AI? No. So we had a conference last year. So we had invited one of the Oxford professor who is working on this. So we posed this question. Is it to best of my knowledge? No. So what are we going to use to give confidence on the system, right? So that is the two things, the assurance, the maturity of the technology. Second thing, as I said, it's always slow to get into cockpit. Everywhere else it has to work. Then only you will allow it into the cockpit. Because if there's one mistake, 300 lives will go. You cannot allow that, right? So the regulatory bodies are very, very careful, very, very careful. So they are taking the right step, putting first we will explore. So they have put a roadmap up to 2021 we'll explore. Then we will do little bit of prototyping. Now by 2024, they have split into 3 phases. First phase, AI will just assist. Now just give some assistance to the pilot. Second phase, they said AI will collaborate with the pilot. Third phase, maybe single pilot or totally autonomous flight. So regulatory bodies are very careful to bring the regulations, guidelines. So this also is coming up. So my opinion is the regulatory bodies are saying by maybe 2025 we'll have that assistance into the cockpit. 2030 we will have the collaboration. 2035 maybe single pilot or autonomous flight. So this is the roadmap. It would take time. It may be we are optimistic, but if we get to that timeline, a lot of things will change. That's my opinion.
Thank you, George. Dr. Pashelkar, you've been listening to all of this, and in your role as Program Director of Civil Aircraft Projects, where you're looking at the aircraft as a whole, and all these things, and you're talking about AI coming into many aspects of the aircraft, but when we look at the aircraft as a whole and the overall systems engineering across the life cycle, where do you think AI comes in, and where can AI really be of help in the overall systems engineering process of an aircraft development?
Yeah, so the reason why, many of the panelists already mentioned that there is a lot of pressure to actually basically make the entire aircraft autonomous, even though it's a civil aircraft, you have fare-paying passengers at the back, and you have fairly big aircraft like 300 plus. So clearly those are all economic reasons, right? So, but as engineers, we understand that, and regulatory agencies, they will not allow that to happen unless there is a certain amount of assurance that what is being done is safe or acceptable from whatever, we have probabilities assigned to various such things, and where it is in the same line of acceptability of any other engineered system. So what my thoughts are that we all, I'm sure all of you are all in some form or the other engineers here, so we understand the concept of interpolation versus extrapolation, right? So you have data, lots of data, and the idea is to ensure that your system performs in a certain well-corralled region, safe region, bounded, and so you test the extremes, right? So you generate data which covers those extremes. So essentially, what you're saying is anything in between, it will work. You assume the system will be, it is designed to be safe and smooth, and that nothing catastrophic is happening in between, and then all the 4 corners. So you design your test vectors. Everything is thought in that sense. Though potentially you cannot ever really test a system 100%. That is a known fact now. If you have billions of lines of code in a F-35 or potentially AMCA or any other aircraft, you're just not going to be able to test every possible combination, and you will discover when the aircraft somewhere is in flight that yes, a certain thing which you thought, like Murphy's law, that it won't happen, actually happened, and then you have not really, it has happened to us as well, so that's a fact. So knowing that we have to deploy a system in a certain time period, but at the same time give a certain level of assurance, which is now based on our understanding of that system. So we are heavily relying on interpolation in some sense. So what I would say is where it is possible to characterize the system behavior in its extremes and determine that anywhere in between it will also be more or less safe or acceptable. I would say data-driven approaches are good, because then you don't have to test all over the place, and then you're gathering data as you go along, and then you're reasonably assured of safety. But when you're trying to assume that the system will do something when it is way beyond those combination of factors which you ever tested or designed the system for, clearly it is extrapolation. And so I would say AI or no AI, I don't think it's going to work. Because if it's going to be data-driven, then it has got to learn from something. What it is learning from is from the data which is inside that range of variables and values and combinations that we have thought through and tested through. Anything outside would, it's just, you're just tossing a coin, I would say, in a sense. So that's my feeling, that for failures which we know that typically where pilot error or other kind of lack of situational awareness, as Captain Aslam was pointing out, those things maybe a machine can correct properly. But where it is beyond the comprehension or of a system designer or even the pilot, for example, I don't think putting an AI on board is going to actually improve anything. I mean, it's beyond that capability. So I would still say all of the testing that we do, all of it is going to be there. Perhaps that where it is possible to eliminate pilot error with a, let's say, a pilot associate, for example. That was being mentioned that, different stages of thing. One is you give it an advisory role. So it just advises, but the decision is with the pilot. The next stage is where it actually takes active control. So which are those conditions where you would like that to do, a machine to take precedence over a pilot? That is really the question.
Thank you. Yeah. Like to open up for questions. So any of you please raise your hand and we'll have volunteers. There's a question on the front row, please.
Hi, sir. I like to question group captain, sir. Sir, we are seeing autonomous and automation in automotives, especially integration of AI in system engineering is very much possible in automobile manufacturing and other things. But if we take aerospace, of course we can do it in UAVs and combat vehicles even, combat unmanned UAV vehicles. And we can push it to aerospace also, maybe because of precision but you are very confident when we are opening up the debate that yes, pilotless aircrafts, but how we can, are we ready to move on to the passenger aircrafts? Unmanned passenger drones are okay, 1 or 2 people flying in short ranges in a very less height, but concerning the safety, how to take off and land and all those critical missions, and also thinking about the recent flight control problem happened in 737 MAX in 2019, which made it to ground for 2 years. It's unimaginable for me, but I like to, being a pilot, you are very...
Yeah, good question, thank you. So certainly those are the same questions I was talking about, winning the public perception. Technology exists. As Mr. George said, technology has gone way ahead. If it were not for the fact that I have to take care of the public perception and make sure certification is safe, systems would have started coming. Now, it will not happen in the way we see with the autonomous drone. It is not that the aircraft will take off and there is nobody monitoring. What will gradually happen, as the roadmap says, in three different models that they are looking at, you will have a stage of 2 pilots to 1 pilot on the ground, and then probably the pilots coming on the ground, but not that the aircrafts are flying on their own. So it has to happen in that safe manner, and that is exactly the same question which all the airworthiness and people in the industry are trying to address and come up with standards which will where we can demonstrate, win the public's confidence that it is safe and that you can now travel. So again, when you ask, the question that comes is, what is the timeline? I think the question is open to answer for everyone. So I'm not sure did I answer your question, because these questions are very, very difficult to answer. How will it envisage?
Yeah, thank you. Yoga?
I have a question to Group Captain Aslam again. Others could also definitely answer that. In your slide, you had put one AI system monitoring another AI system. One AI itself is kind of complicated, and we are looking at one more AI looking at this AI. Maybe one is trained in English, other is trained in Hindi perhaps, and they are looking at each other. What would be the challenges you see? I mean, this is one of the points that you could perhaps have, or you could have a classical thing monitoring an AI system. What are the challenges you see if you have such a situation?
So, sir, the example I would take, sir, is the same tool that you are using for display systems certification. So that's an AI-based tool that you have devised, your team has made. In the same way, the tool, as you have said, the tool is, the gentleman with the camera, sir. Yeah, thank you. So the tool is certified. You are saying it is certified DO 178. So that is the way we'll have to do. We won't be able to launch an AI tool to test an AI aircraft altogether. It will be in gradual steps. In fact, the question being asked is, do I even need a flight test engineer for certification? Can it be an AI? So I will be unemployed, so to say. So that is how it will be approached. It won't be, those are ideas on the table of how to do it. But how to make the regulation, as you say, we are struggling with just the AI on the aircraft. Now we have to take confidence in an AI system doing the certification, big mountain to climb. But definitely, those are some of the ideas. We can start in some small way, just the way you have done for the display systems, and then bring those things also onto the aircraft systems.
Thank you. Any other question? Any other question?
Yes, sir. I have a question related to systems preventive maintenance using AI. So what would be the, from here, this corner.
Yeah.
So what would be the role of AI, we know the role of AI in preventive maintenance, but is it being used in the current scenario? Because preventive maintenance or on-ground maintenance, all these things do not have such risk associated to AI. So is it being currently deployed?
Try. Okay, I'll try. So there are some effort made. There's one software from GE that's pretty famous. Honeywell has got a tool to do that. But one thing we need to keep in mind, it is not only analytics and software. It's about instrumenting, getting data, and then doing analytics, right? Say, for example, you take wheels and brakes in aircraft. So traditionally, after so many landings and takeoff, you replace it, or when it fails, it replaces. But if you have a sensor that can sense and then give you feedback, you have a better way to do it, right? So you need to get it instrumented, collect the data. So there's a lot of effort going on currently. So instrumenting the engine, instrumenting the landing gears, these are all in the stage of evolving. All the equipment manufacturers, so each one will have their own programs. So my thought process is, my opinion is, the IoT is changing this game a lot. Maybe a few years down the line, we would have all that equipment kind of instrumented. That would give you an opportunity to do preventive maintenance. But algorithms are there. So many tool vendors, they make predictive tools, predictive maintenance tools. But important thing is collecting data, instrumenting and collecting data.
Thank you. I think we are coming close to the end of this. I'll maybe take
one question.
Yeah, I'll take one question from there, please. Or
yeah, okay, continue?
Go ahead.
Sure.
Yeah.
So I have a comment for Dr. Pashilkar. He made a very, I thought, insightful statement that interpolation is very different from extrapolation. And we sort of assume there's an inherent reliability in interpolated solutions. But with an AI system, where do you even define the boundaries? How do you say what is interpolated and what is extrapolated?
Yeah, so in the context of the transport aircraft, which the question was posed, what I would still say is we do have a catalog of various accidents and incidents, and then there is an investigation, and we figure out what is the root cause, right?
Right.
So we have fair amount of data. It could be even a system, for example, which you have deployed in the field, and you would then get back those systems and data along with that. So if you are then having sufficient amount of that data, in that sense, you have samples of a whole lot of those systems in different parameter space, right?
Right. You can define this quite well in your external parameters, but what about the AI's internal parameters?
Yeah, so that is where the question comes that what is the AI actually doing? And if it is data driven, it is basically trying to memorize or in some way create a hyperdimensional, whatever, mathematical construct of that, which you give multiple inputs and it will give out outputs, and you can train that network based on all this data that you have collected. So that kind of a problem is fairly well posed and well understood in a mathematical sense. And so where such a paradigm is applicable, you can start thinking of using AI and replacing it, for example,
Okay.
from any other traditional, even a design process, for example.
Right.
Or a maintenance process, for example. So that would be, for example, you're trying to do debugging of what's possibly the root cause.
Right.
And you have data for it. And I think the gentleman mentioned that, with IoT, you could potentially in the future have lots of data of lots of parameters.
Right.
Now, if you humanly want to sit and look at all the parameters and make sense of it, probably it's not a good idea. And so where it is data driven and where you have sufficient number of data covering the domain of interest, I would say still you should think of deploying an expert system or a neural network or something and train it on that data.
I see.
And then the chances are that it will give out with certain accuracy, say 95 percentile accuracy, a good diagnosis of what possibly has gone wrong. So that is where, the problem is well posed and you are in the domain of data which you already have. I would still say you should deploy. I mean, why not? You have the tools for it. You have all these neural networks or other kinds of machine learning algorithms, and why not deploy it? Because it is economical to do so. And today, it's computationally possible to do so. So that's where I would say we should adapt AI straight away.
I see.
Thank you.
Thank you.
Where it is
I have a
not-
question for Group Captain Aslam Khan, if I may, if you will permit me.
Yeah, be quick, please. Yeah.
You mentioned that you suggested that different certification procedures will have to be adapted. I did not understand entirely all the details you went into, but it sounded very similar to let's move the goalposts to me. So, बच्चा पास नहीं हो रहा, थोड़ा pass percentage कम कर दो. How was I wrong in this perception? Thanks.
No, that was not the intention at all. That is not the way regulatory bodies work. The way they are thinking about is the learning assurance, how do I guarantee, and as all of us have talked about, right? How do I ensure that the learning assurance or the neural network is learning from the data that I have presented, and I have bounded control over the weights that it has assigned itself when it is learned and then goes to the aircraft. So the entire focus of your trustworthiness will start from there. And one more thing we must understand, we are not going to use, there are ideas where we say, why should I use the same Java, C, C++ to develop an AI system where conventional systems are getting, software are getting written. So there are people like in the World Economic Forum in Davos, there was discussion on coming up with a probabilistic programming language to make sure that AI systems are curtailed right at when you are building the system, you're using these kinds of programming language. So there is work going on even to build this kind of syntax to take care of all the data handling, interpolation, boundaries, all of this. So put all of that together. My intention was not to convey we are lowering in no way.
No, I meant to say that I misunderstood, and I'm sure I was wrong, and I was requesting a correction from you.
Yeah, absolutely. It will be as tough, if not more tougher, to convince our regulators. We see that in all our daily work when we work with FAA, DERs, and European agencies.
Thank you.
Okay.
I think we have come to the end of the panel. We have spent a good 1 hour. We heard a lot of things from the stage, and thank you for your interaction as well. I strongly encourage you we are going to go on a break now, so please stay back, interact with the panelists, and this is a topic that is going to be relevant and something that we are going to be dealing with, each one of us, wherever we are in the aerospace domain. So I would like to conclude by giving a chance to all the panelists, just a quick 1-2 sentence concluding remarks, starting from you, Dr. Pashilkar.
Yeah, so firstly, thank you for the opportunity to share my views. We did do a little bit of work on that sensor fusion stuff and all that, where I would just say that we try to build a model of the pilot in a sense how he does threat assessment. So it's not that these things are not being done, probably whether we are good or possible, I don't know. It was never really tested in that sense. So, but these are all things which I think it will come in. There is no doubt about it. There are various reasons, primarily economic, and because now we can do certain things. So I'm sure it will come in.
Thank you, sir. Group Captain Aslam.
Yeah, thank you for this opportunity. All I'm saying is we have exciting time ahead. And I hope all the youngsters continue to have faith in AI system and AI systems in the aircraft, and all of them will work in this industry and make it a success. Thank you.
Yeah. George?
Yeah, so couple of things. One, I don't think our certification authorities in any country would let AI in if they don't have the confidence. So there is absolutely no compromise on the assurance. Only when they are sure that this methodology will give the same product's assurance like the earlier systems, it would be let in. That is for sure. Second thing, a lot of work has to be done. Will Tesla drive in Bangalore traffic? I don't know. Either Tesla will not move or 5 people will get hit, right? So if you compromise, 5 people will get hit. If you don't compromise, Tesla will stand there only. So, right, it will not move because every two-wheeler, every auto will fall in front. So, same way AI is working everywhere. Will it work in aero into the cockpit? That we have to do a lot of work. That's what the entire industry, lot of work is being done. Work groups are working to mature it, put enough guidelines for certification, giving confidence so we can take advantage of it. That's what I would say.
Thank you, George. Dr. Narayan?
Okay, as the beginning of the program, we told system engineering and artificial intelligence are having a mutual coexistence. So in the days to come, for space systems, system engineering is very well anchored and laid a solid foundation. So artificial intelligence will take over the system engineering concept by going right now with the manual override to supervisory control to finally to executive control. And I would like to wish and see that when the dawn of AI is there in the space systems, where we can talk about much more refueling of the spacecrafts or enhancing the longevity of the spacecrafts, as well as replicating and duplicating the spacecraft in orbit, so that the time and money, because it's a very costly proposition in space, so this can be avoided, and this one can be made after cost optimization can be taken up in a big way. And AI, according to me, AI is here to stay, and it is going to take rapid strides in the days to come. Thank you for this opportunity.
Thank you very much, Dr. Narayan. Thank you all. On the slide here, I just have a few resources if you are interested to know more about systems engineering and AI. INCOSI has an AI working group. There's an INCOSI magazine which had a special edition on artificial intelligence. There's an edited book, Systems Engineering Artificial Intelligence, which has a number of interesting articles. And also the CBOC, the Systems Engineering Body of Knowledge, has an article on artificial intelligence. So thank you all. Thank you all to the panelists, and thank you, Ramki.
That was a really wonderful discussion. So on behalf of AeroCON Organizing Committee, I would like to thank all the panelists. And I would invite Mr. Damodaram Subramaniam, former MD, Software Engineering Services, and Chair of AC India Bangalore section, to honor the dignitaries on the stage. So thank you. So we'll take a tea break till 4:30. We'll come back to topics such as